Hello guys. Hello again guys. Good evening. It's me again, Patrick Atigbak. For now, I create a summary in chapter 7 titled IP addressing. Let's go for that to our summary. So, Chapter 7 IP addressing. Chapter 7 in section on objective. 7.1 IPv4 network addresses explains the use of IPv4 addresses to provide connectivity in small to medium-sized business networks. It may convert between binary and decimal numberings. Describe the structure of an IPv4 address, including the network portion and the host portion, the subnet mask. It compare the characteristic and uses of the unicast, broadcast, and multicast IPv4 addresses. Explain public, private, and reserved IPv4 addresses. 7.2 IPv6 network addresses. Configure IPv6 addresses to provide connectivity in small to medium-sized business networks. It may explain the need for IPv6 addressing. Describe the representation of an IPv6 address. Compare types of IPv6 network addresses. Configure global unicast addresses. Describe multicast addresses. For the 7.3 connectivity verification, use as common testing utilities to verify and test network connectivity. Explain how ICMP is used to test network connectivity. Use ping to traceroute utilities to test network connectivity. For the 7.1 IPv4 network addresses, binary and decimal conversion. Binary numbering system consists of number 0 and 1 called bits. IPv4 addresses are expressed in 32 binaries, bits divided into 4 to 8 bit content. In the picture, we will see the IPv4 addresses expressed in binary. Let's see what it is. That's the binary numbering system. IPv4 addresses are commonly expressed in dot decimal notation. Another picture, see it. There's a LAN A network address and the LAN B network address. Converting binary numbering system. This video will cover the process and ending it relates to discovering the network address, the host addresses, the broadcast address in IPv4. First, positional notation. First row identifies that there's a two images, so we will explain it. The first row identifies the number base of radix. Decimal is 10, binary is based on 2. Therefore, radix will be 2. The second row considers the position of the number start with 0. This number also represents the exponential value that will be used to calculate the positional value of fourth row. The third row calculates the positional value by taking the radius and increasing it. By the exponential value of its position. Note is 0 is always equals to 1. The positional value of is listed in the port row. So there's two pictures. So positional notation ko. So binary to decimal conversion. To convert the binary IPv4 address to decimal, enter the 8-bit binary of each octet under the positional value of row, and then calculate produce the decimal. So there's a positional value, binary number, calculate, and add them up, and the result. So in the end, there's the dotted decimal notation. So there, decimal to binary conversion. So to convert the decimal IPv4 address to binary, use the positional chart. So and check first if the number is greater than 128-bit. If no, A0 is placed in this position. If yes, then A1 is placed in this position. So 128 is the subtracted from the original number, and the remainder is then checked against the next position, 64. If it is less than 64 and 0 is placed, so it is in this position. If it is greater, 1 is placed in this position, and 64 is subtracted. So the process repeats until all positional values have been entered. So there's a decimal to binary conversion samples. There's a four pictures. So let's go to another. So IPv4 and host portion. An IPv4 address is hierarchical, composed of a network portion and host portion. So all the devices on the same network must have the identical network portion. So the subnet mask helps devices identify the network portion and the host portion. So for the subnet mask. So the subnet mask. So there's a picture in the side. So Internet Protocol version 4, TCP IPv4 properties. So let me explain it. So the 3 IPv4 addresses must be configured on a host. So it will be unique IPv4 address of the host. Subnet mask that identifies the network host portion of IPv4 address. Default gateway IP address of the local router interface. So the subnet mask, the IPv4 address is compared to the subnet mask bit by bit from left to right. 1 in the subnet mask indicates the corresponding bit in the IPv4 address is network bit. So the local AND. The local AND is one of the 3 binary operations used in digital logic used to determine the network address. So the logical and the 2 bits yields the following result. So 1 and 1 equals 1, 0 and 1 equals 0, 0 and 0 equals 0, 1 and equals 0, 1 and 0 equals 0. So there's a picture. So this is the prefix length. So the prefix length shorthand method of the expressing the subnet mask equals the number of bits in the subnet mask set to 1, written in slash notation followed by the number of a network bit. So that's all for now. So this is the summary of the chapter 7 titled IP addressing. So please don't forget to subscribe in my channel. Thank you.